This video covers the addition rule, which builds on our ideas from the Venn diagrams in the previous videos. So if you have a card that's drawn at random from an ordinary pack of 52 playing cards, find the probability that the card is a spade or a queen. I've got the cards down below here. You should be familiar with what's in a common deck of cards. Okay. So here we've got find the probability that the card is a spade. So 13 spades in a deck and 4 possible queens. So the first thing that you can do is draw a Venn diagram. So in order to set that up, we've got the box that represents our whole sample space, so 52 cards. Then we've got the cards in this circle that are a spade, this circle that's a queen, so we've got S and Q, and then in the middle is where they are going to intersect. So for spades, we've got ace, see if I can fit them all in here, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, that's also a queen, and then a king. And over here, I'm going to have the queen of hearts, the queen of diamonds, and then the queen of clubs. So I only have one item that intersects. So once you've drawn your Venn diagram, then you need to figure out what are you looking for. So in our case, we're looking for the probability that we're going to draw a spade, or, that's the union, a queen. And so to find that probability, we need the number that are in that set over the total number in our sample space. So we have both of those things now. Okay, we've got, how many do we have in that space? We have number of spades. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we've got, how many do we have in our other one? Plus 3, and then plus 1 in our intersection. And then we're going to divide by our total number of cards. So we'd have 12, 15, 16 over 52, which is going to simplify to 4 over 13. Your formula book also has a formula that breaks this down a little bit more analytically. And you can write this as the number of spades plus the number of queens, and then you're going to take away the number of their intersection. And as you can see, you're going to end up with the same result. So let's take a look at our next example here. You've got a Venn diagram with two events such that the probability of event A is 9 over 20 and the probability of event B is 3 over 10. You also are given the fact that the probability of the union of A and B is 2 times the probability of A and B. So we are going to try and find the probability of A or B first. So let's fill in our Venn diagram. We've got 20 in our set. We've got A over here, B over here. We know that we have our probability. Okay, we seem to be at a bit of an impasse because we don't have enough information. So let's break it down using our equation. So we've got the probability of A or B is going to be equal to our number in A plus our number in B, take away our number in A and B, all over the total number in our set. okay? So let's now break that up into some different pieces. We've got our probability of A or B is going to be the same as this here. And here I'm doing some work with fractions. I'm rewriting what I have in 3 separate pieces. So what you should recognize is that now that I've done this here, here, and here, I can rewrite the right-hand side in terms of probabilities. So I've got P of A or B is going to be the probability of A. Remember, I know that from the question, plus the probability of B, also know that from the question. Take away the probability of A and B. Now, to save myself a little bit of writing, I'm going to say let X equal the probability of P, of A and B there. Okay. So the other piece of information that I can replace is right over here. I know that the probability of A or B is really equal to the probability of 2 times the probability of A and B. So that's going to let me make some substitutions. So my left-hand side is going to be 2x. On the right-hand side, I'm going to have 9 over 20, just from my question, plus 6 over 20, and then I'm going to take away x. Now I've got an equation that I can solve here. And when you work that all out, you should get that x is going to equal 1/4. So that's kind of interesting. So now I can take that to the probability of A and B is going to equal 1/4. That is going to let me fill in my Venn diagram. I know that that has to be 5 because that's 1/4 of 20. Now I can fill in what A is going to be, 4, and B, so 6, so I would have B would be 1 here, okay? So now what I want to remember what I'm looking for. Now that I've done my Venn diagram, I'm really looking for the probability of A or B, which is going to be 2 times 1/4, which is going to be equal to 1/2. Which, if you look at the Venn diagram, you do get 1/2 when you add up the 3 parts of the Venn diagram. 4 plus 5 plus 1 is 10 out of 20, which is 1/2. Okay, so let's find 2 other pieces of information from this question. Part B that we're going to do here is the complement of the set that we just found. So everything that's not in those circles in the Venn diagram. So here we can use the fact that the probability of the complement of that plus the probability of the union is going to be equal to 1. We just solved for this here, so we know that the probability of A or B complement is equal to 1 minus the probability of A or B. And based on the information that we have above, that is going to be equal to 1/2. Okay, so one more example here. Here we're doing the probability of A and not B. So on a Venn diagram, this is the A circle minus the intersection part. So it looks sort of like a Pac-Man circle. So our probability of A and not B is going to be the probability of A, take away the probability of the intersection, because we want to remove all those members that are in A and B. So our probability of A is 9 over 20. Our probability of A and B is 1/4. And subtracting those 2, you get 4 over 20, which is the same as 1/5. So some neat applications of the Venn diagram, you can always shade in the different pieces to give yourself a graphical representation of what you're actually calculating. Okay. The second piece of this is what's called mutually exclusive events, and that's where you have events where two outcomes can't occur at the same time. The circles just don't overlap in the Venn diagram. So for example, if drama and German are in the same time slot, students can't take both. So out of 100 students, we have 38 take drama, and we've got 32 take German. That leaves us with 30 left over. So that means that our number in the intersection is 0. The probability of being in that group is 0. And for mutually exclusive events, the probability of D or G is going to be the probability of D plus the probability of G, take away 0. So same equation as before, except that intersection now you know to be 0, so it changes the equation a little bit. So in general, if A and B are mutually exclusive, then it follows that the probability of A and B equals 0, and therefore the addition rule changes from the general form that we had above, is the probability of A or B is just equal to the probability of A plus the probability of B. Okay. So for example, we're going to do a mutually exclusive one before we finish up. In the math office cupboard, there's a container with multiple colors of pens. If the probability of selecting a red pen is 1/4, and the probability of selecting a blue pen is 5/10, what's the probability of drawing neither a blue or a red pen? So our events are mutually exclusive because you're only drawing one pen at a time. Okay. So let's let R represent our red pen drawn, and let B represent the blue pen drawn. And so we can write our addition rule as the probability, no tails on your union symbol. Because they're mutually exclusive, this is what we can say about the probability of drawing, well, red or blue. So we've got 1/4 plus 5/12. Great, some fraction work. When you add those together, you should get 3/4. Now this is fine, but we don't actually want the probability of red or blue. We want the probability of neither red nor blue. So we want this. So we need to do 1 take away the probability of R or B, which is just going to give us 1/4, which is the probability of drawing neither a red pen nor a blue pen.